Let's say that matrix A is this 2 by 2 matrix. If I were to find the determinant of that matrix, the notation would be det of matrix A, or capital A with what looks like absolute value symbols around the A, but this time we are talking about the determinant. So how do we tell the difference between the determinant and absolute value? Well, it has to do with context. In this case, A is a matrix, so these symbols mean absolute value. There are two different forms of the notation for a determinant. To find the determinant of this 2 by 2 matrix, I'm going to first look at the diagonal starting in the upper left corner, and I'm going to take 1 times 5. And then I'm going to look at the diagonal starting in the lower left corner, and I'm going to take 2 times 3. So I'm going to take my down diagonal and my up diagonal and subtract those two numbers. I'm going to take 1 times 5 and subtract 2 times 3. So the determinant of this 2 by 2 matrix is -1. The formula for a 2 by 2 matrix. If I just have a matrix A, B, C, D, and these symbols mean determinant, if I were to take the determinant of this matrix, I'd end up with the formula for a 2 by 2 matrix. A times D minus C times B. We can only take the determinants of square matrices, where our rows and our columns are the same. This is the formula for a 2 by 2 square matrix. Now let's look at a 3 by 3 matrix. A 3 by 3 matrix becomes a lot more complicated. My first diagonal, 2 times 0 times 4. But now I have a second diagonal, -1 times 1, and then I run out of room. If you remember the game Pac-Man, if you were going along in Pac-Man and you exited the screen on the right side, you would pop out of the screen on the left side. So once I exit the matrix, think of Pac-Man and pop out here. So I'm going to take -1 times 1 times 1. There's a trick to remember that. I'm going to repeat the first 2 columns in my matrix just to the right of my matrix. So now I can keep going with my diagonal. -1 times 1 times 1. 3 times -2 times 2. Now these are all my down diagonals, so I'm going to add all of my down diagonals together. Make sure that I have 3 down diagonals. Now I need to look at my up diagonals. I'm going to start in the lower left corner. 1 times 0 times 3. 2 times 1 times 2. 4 times -2 times -1. These are all my up diagonals, so I'm going to add all of my up diagonals together. So I have all my down diagonals added together and all my up diagonals added together, and just like this formula where I did down minus up, I'm going to do the same thing here. down, minus, up. Now I need to follow the order of operations. I'm going to first perform all of the math inside of the parentheses before I do any subtracting. 2 times 0 times 4 is 0. Negative 1 times 1 times 1. 3 times negative 2 times 2. It's going to give me negative 6 times 2 is negative 12. I'm going to perform all of this math. 1 times 0 times 3. 2 times 1 times 2. 4 times negative 2 times negative 1. 4 times negative 2 is negative 8. Times a negative 1 gives me a positive 8. So now I have 0 plus negative 1 plus negative 12 gives me a grand total of negative 13. 0 plus 4 plus 8 gives me 12. Negative 13 minus 12 gives me a grand total of negative 25. So to find the determinant of a 3 by 3 square matrix, repeat the first two columns, collect all the down diagonals, add those down diagonals together, collect all the up diagonals, collect all those up diagonals together, and subtract down minus up. Now, a little bit like solving a three-variable system, the process is not the tough part. It's executing and making sure that you keep track of all the numbers and you do the little things right, like take care of negative signs. And don't forget to repeat negative signs. If this is a negative 1, make sure it's a negative 1 over here. The formula for a 3 by 3 matrix, I'm going to leave up to you. It's fairly complicated, but if you can figure it out, you have a high level of math thinking.